In this lesson, we're going to continue to study characteristics of functions. We're going to start by talking about increasing and decreasing intervals on functions. So if we have a function, if as you examine it left to right, and it must be as you examine it left to right, if it rises, then it is increasing from the point where it started until it ends. If instead, as you examine it from left to right, if the curve is decreasing, if it's going down, then it is decreasing. So what you have to look at is at what point does it change and begin to go down, or change and begin to go up. And these intervals, remember, we're looking left to right, so they are all x intervals, meaning from what x to what x is it occurring. These will also be open intervals, so they will all have parentheses. So here we go. Use the graph to determine open intervals on which the function is increasing, if there are any. So looking at this graph from left to right, here to here, you can see that it is increasing. So we need to now see, what are the x's? Well, even though it's going down, it is starting, I'm looking this interval. So that will be from negative infinity till, okay, what is the x value of the point where it changes, which is right up here at the top, and that looks like it is negative 2. So from negative infinity to negative 2, it was rising. Now, from negative 2 to where is it falling? Okay, let's see. Decreasing, it is decreasing from negative 2, and it decreases for the entire rest of the domain, so I'll put infinity. So from negative infinity to negative 2, it increased, and then from negative 2 to positive infinity, it decreased. Now, some people might say, wait a minute, you're going down. How can you possibly be increasing? I'm talking about the x's. So from negative infinity till negative 2, it did climbing, and then from negative 2 to positive infinity, it fell. The next part says, was it constant? Now, I didn't talk about it up here, but if we go left to right and it stays level, then it is constant. And this function is never constant. So that would be choice B. Let's look at the next one. All right, on this one, same 3 questions. They might be asked in a different order. So, open intervals on which the function is decreasing. Now, if I track in an x direction, remember I'm supposed to look from left to right. The curve is increasing, increasing, increasing. It's always increasing. So from this x value of -2, and then it does not go forever, to this x value of 3, it increases all of that time. So it's never decreasing. Increasing is from -2 to 3, and it is never constant. Oops, wrong one. All right. And it did say open intervals, and that always tells you to use parentheses. All right, now I'm going to enlarge this. So I'll fill in this part in just a minute. Let's just look at the curve. What is it doing? It is increasing till it hits here, and that, by the way, is 2. And then it's decreasing till it hits that value, which is 3. Then it's increasing again till x hits the value 4, and then it's decreasing all the way to infinity. So it started at -infinity till it went to 2. So I think I'll do this. From -infinity to 2, it was increasing. So I'll go ahead and put that. -infinity to 2, that's on the increasing. Then from 2 to 3, it was decreasing. And it says if I need to put more intervals, use a comma to separate them. Okay, from 3 to 4, it's increasing again, comma, 3 to 4. And then from 4 to all the rest of the x's that are positive, it's decreasing. So that will be from 4 to positive infinity. It was falling, so it was decreasing. And it was never constant. All right, in our next question, we're going to continue with the discussion about increasing, decreasing, and constant. Remember, you must look at the graph along the x's. So starting at -infinity until x hits 3, what is the graph doing? It is decreasing. So I'll go here and say from -infinity to 3, it was decreasing. And then from 3 to positive infinity, what's it doing? It's constant. So that's down here from 3 to positive infinity. You're always answering the question, for what x's is it doing this? And for increasing, as I look at it from left to right, this curve is never going up. So there is no increasing. All right, new question. It says the graph and the equation of the function are given. Use the graph to find any values at which f has a relative maximum. Use the equation to calculate the relative maximum for each value. And then we'll do the same thing for the minimum. All right, I'm going to get an opportunity to show you how to do something with your graphing calculator. So here is our equation. And the first thing I'm going to do is take my grapher and hit y equals. And I'm going to clear out anything that I already had in there using my up and down arrows and hitting clear. All right, I'm going to type this function in, and remember that f of x is the same thing as y. So y equals 2 variable x raised to the third power. I'm going to use my right arrow to get out of the exponent, plus 3 variable x squared minus 12 variable x plus 8. Okay, so double check and make sure that you have your function in there correctly. I am going to look at my instructions, and it has the window. The first one will be the x's. So this will be x min. This will be x max. And don't worry about that. That's the scale. We don't have to worry about it. This will be y min. This will be y max. And we won't worry about that. So back to my grapher. Go to window. The x's, -5, down. It already had +5, so scale, you can leave it as 1 or you can skip it. Y min is -35. Y max is +35. Now I didn't predict that would be the best window. I was given the window settings. All right, back to the picture. Now hit graph. The graph is identical. The only reason anything looks different is that I didn't worry about the scale, and the scale is how far there is between the tick marks, and I left it at 1. They had it as 5. That doesn't matter at all. All right, we're supposed to find any relative maximum. Now, a relative maximum just means top of a hill. That's all it means. Relative maximum is top of a hill. Let's see. Relative minimum, that's going to be the valley. So the relative maximum is here. The relative minimum is here. Now, different books state this differently, but it says the function f has a relative maximum at, you're going to give the x coordinate of the maximum, and the actual relative maximum, and it's singular or plural, is, and this will be the y value. Okay, now let me show you now, and this is in your formula packet. If I want to find the coordinates of the maximum, what I'm going to have to do is do second of the trace key, which is calc. We've used it for intersection before, but we're going to choose number 4. Whoops, which is maximum. What you have to do is sandwich the maximum. The maximum's right here. You need to put a marker on the left and a marker on the right. Let me show you. Use your left arrow key and it will move the marker, go past that maximum till you're on the left side of it. I don't care how far, but on the left side. Hit enter. Now use the right arrow key till you're on the other side of the maximum and hit enter. You can see that you have marked it on the left and marked it on the right. It's as if you have made the maximum a sandwich. Now, it gives you the opportunity to guess, which is kind of silly, but we'll just hit enter again. It has the marker at the maximum, and then it has the coordinates down here. The x is -2, and the y is positive 28. So, -2 and 28. So, the point is -2, 28. But the way they say it, it has a maximum at the x value of -2, and that highest point is 28. All right, so this is what the grapher told us, but we had to read the question and understand. Next, we'll do a minimum, and it says a minimum at, you're going to get an x value, and the relative minimum is, and you're going to give the y value of a minimum. Now the minimum is over here, and you're going to sandwich it again, marking it on the left and marking it on the right. You have to hit second of the trace key, which is calc. I'm going to choose number 3. I'm just going to hit a 3. And it's ready for me to do a minimum, but I have to go and I have to set my sandwich, and it's always left piece of bread, then right piece of bread. Okay, I'm on the left side of the min. Enter. Pass through it. I'm on the right side of the min. And you should be able to tell that you have marked it between these two. And when it says guess, just hit enter. And the minimum is at 1, 1. That is very hard to tell that that's up to 1, but that's because this viewing window is 35 down and 35 up. So there's 70 tick marks here, and this is up one of those little tick marks. So it has a minimum when the x is 1 and the minimum value is 1. The point was 1, 1. So the minimum, the relative minimum at, that means at what x, is 1. And the actual minimum means how high up or how high down it is, and it was 1. Okay? I know that's a little bit crooked, but, well, let me go back here for just a minute. Whoop. So on maxes and mins, you're going to do second calc, either max or min, and then the important thing is you're going to hit it on the left, enter, right, enter, and then just enter a third time, and it will put the maximum. Then you'll do it again, second calc minimum. You will click it on the left, enter, on the right, enter, and then enter again, and you will have the minimum. So those steps are in your formula packet. All right, something else we need to talk about with functions is symmetry. All right, the graph of an equation is symmetric with the y-axis if for every point xy there is also a point -xy. Now what that means is if you have a graph and it looks like this, if you have a point over here, you will have a matching point equidistant on the other side of the y-axis. So in other words, if this is the point 2, 3, if it has y-axis symmetry, then it will also have the point -2, 3. Graphs that have symmetry with respect to the x-axis are not going to be functions. But what that means is if you're symmetrical with respect to the y-axis, now you can see this, if you're symmetrical with respect to the x-axis, then you're going to fail the vertical line test. But so if you have a point here and a matching opposite point here, then you are symmetrical with respect to the x-axis. So if you had the point 2, 3, you would also have the point 2, negative 3. With respect to the origin, would be a graph like this. So if you have a point here, let's say this is 3, 4. If it is symmetry with respect to the origin, then you will also find the point negative 3, negative 4. So symmetry is like reflecting. So if it is up here at the top, if it is symmetrical with respect to the y-axis, then the y-axis acts almost as a folding line. If it has symmetry with respect to the x-axis, then the x-axis acts as a folding line, and it's identical on both sides. If it is symmetry with respect to the origin, then it's going to be in the opposite or diagonal quadrant, and both the x and the y will be opposite in sign. All right, so we have tests over here, and it says what to do. For with respect to the y-axis, you're going to put in negative x in the place of x, and it should make no difference. With respect to the x-axis, you're going to put in negative y for y, and it should make no difference. The x's will be the same. And if you're testing for symmetry with respect to the origin, you do both. So let me show you how this formal testing goes. Let's test with respect to the x-axis. All right, you're going to substitute negative x for x. And I have y is equal to x squared plus 13. When I substitute, y is equal to negative x squared plus 13. Well, if I square negative x, I get x squared plus 13. So when I put in negative x in the place of x, it didn't change anything. So if I look up here, okay, I'm so sorry. Let me fix something. Whoops. All right, I'm so sorry. I wrote x, and yet I'm working on y. So with the y-axis, you substitute negative x for x. This is identical to this, so it has symmetry with respect to the y-axis. Now let's test the x-axis. You substitute negative y for y. So I start with y equals x squared plus 13. Plug in negative y for y. So negative y is equal to x squared plus 13. Well, these are not the same. So no x-axis symmetry. Origin, you substitute negative x for x and negative y for y. So I start with y equals x squared plus 13. Is negative y equal to, parentheses, negative x squared plus 13. Well, I'll leave that as negative y is equal to negative quantity squared becomes positive x squared plus 13. Compare these, and they are not the same. So it's no. So I tested y-axis, x-axis, and origin, and I got y-axis, and that's the only kind of symmetry it has. Let's take a minute. They said don't do it graphically, but I think it's a good idea to look at it. Go to the y equals, clear, type it in as x to the second power plus 13. I'm going to do a zoom 6. I don't see anything, so I will just go to Window, and I think if I had looked at this, I would remember that it's added a 13. That means it's shifted up 13. So in my window, I'm going to go to Y max and make it be 20. There it is. Can you see that this graph does have symmetry with respect to the y-axis? And that's what our test showed us as well. All right, the next one, I'm going to test y-axis. I put in negative x for x. I start with x is equal to y squared plus 3. So negative x is equal to y squared plus 3. There's nothing I can do to simplify that and change it. And these are not the same. So no symmetry with respect to the y-axis. X-axis. Put in negative y for y. And I start with x is equal to y squared plus 3. So x is equal to negative y, quantity squared, plus 3. X is equal to y squared. Negative quantity squared is positive, so it's y squared plus 3. Compare these. Ah, they're the same. So yes to x-axis symmetry. We said that if something has x-axis symmetry, then it is probably not a function. And we said earlier that when an equation has an even power of y, it's not a function. So that's making sense. For the origin, you're going to replace negative x, put negative x for x, negative y for y, and we will have x squared. Oh, sorry, there's no x squared. I need more room. The original is x is equal to y squared plus 3. So put in negative x is equal to parentheses negative y squared plus 3. That's negative x is equal to negative y, quantity squared is y squared plus 3. Compare what you started with and what you ended with, and these are not the same. So no origin symmetry. This one has only x-axis symmetry. All right, testing again. Let's test for the y-axis. So negative x in the place of x. So y squared is equal to negative x, quantity squared, plus 11. I'm sorry, let me start by writing the original. Y squared is equal to x squared plus 11. So y squared is equal to negative of x squared plus 11. And if I simplify that, y squared is equal to x squared plus 11. compare, and they are the same. Therefore, we do have y-axis, so I can go ahead and choose it. Then if I check for x-axis, I'm going to put in negative y for y. The original is y squared is equal to x squared plus 11. So when I change it to negative y quantity squared is equal to x squared plus 11, simplify, y squared is equal to x squared plus 11. Compare. They're the same. So we also have x-axis symmetry. Then finally, I'm supposed to test it for origin, and I'm going to put negative x for x, and I'm going to put negative y for y. So I have the original, y squared is equal to x squared plus 11, parentheses, negative y quantity squared is equal to negative x squared plus 11. Simplify, that's y squared, that's x squared plus 11. Compare, they're the same. So this relationship had all three kinds of symmetry. And it's not a function though, because remember, if the power on the y is even, it's not a function. I have one more that I want to test. And let's see, y-axis, negative x for x. So the equation is y equals 6x plus 7. Y equals 6 times negative x plus 7. Y equals negative 6x plus 7, multiplying a positive times a negative. So here's the original. Here's the one after I substituted negative x for x, and these are not the same. No y-axis symmetry. X-axis. We're going to test negative, we're going to put negative y in the place of y. The original is y equals 6x plus 7. So this is negative y is equal to 6x plus 7. And nothing to simplify. These just simply are not the same. So no x-axis symmetry. Origin. I start with y equals 6x plus 7. To test for origin symmetry, I put negative x in the place of x, and I put negative y in the place of y. So negative y is equal to 6 times negative x plus 7. Let's simplify this and see if it's the same. Well, that's negative y is equal to negative 6x plus 7. There's nothing I can do. These are the ones I'm comparing, the original to the changed, and they are not the same. So it is none of these. So when you test for symmetry, I've talked a little bit when we started this about a description of y-axis symmetry. That means that whether it's negative x or positive x, the y's are the same. If it's x-axis symmetry, first of all, it's not going to be a function. And this says if it's whether it's positive y or negative y, that the x's will be the same. Origin symmetry says that if you change both the x and y, you still get a point on the graph. So the testing, though, can be a little bit tedious if you have to do a lot of them, and we had to do about 4 of these. Oops. Now, we're going to move on after symmetry and talk just about 2 other words that can be used to describe functions, and these 2 words are even and odd. An even function has y-axis symmetry. It's just another word for it. An odd function has origin symmetry. There is no word to describe x-axis symmetry because these are words used only for functions. Now, we could test it, and if a function has y-axis symmetry, then we could say it's even. And if it has origin symmetry, we could say it's odd. But we're going to do it an easy way. We're going to look at only functions that are made up of polynomials. Those are those expressions with powers of x that we studied when we did factoring. If the exponents on the x's are exclusively even, then the function is even. If the powers of x are exclusively odd, then the function is odd. And that's all there is to it. So let's look at this first one, number 10. Let's look at the powers of x. This power of x is 5, which is an odd number. This power of x is an invisible 1, which is also an odd number. That means that this function is odd. And if a function is odd, then it has origin symmetry. All right, let's look at the next one. It's so much easier to do this. Let's look at the exponents. This exponent is even. The invisible 1 exponent is odd. And when you have a mixture, you have neither. And because it has neither here, it has neither kind of symmetry. All right, let's look at one more of those. This exponent, which is a 2, is even. This exponent is a 4, which is even, which means the function is an even function. And if it is even, it has y-axis symmetry. There is information about the testing for y-axis, x-axis, and origin symmetry and meanings of even and odd all in your formula packet. All right, we're going to now just see if we can figure out everything in the world about a given function. All right, looking at this function, and it does pass the vertical line test, so it is indeed a function. The first thing it says is, what is the domain? Now the domain is the smallest x to the largest x. And this is from negative infinity toward positive infinity. So that's its domain. Next, it wants to know the range. Now the range of this is bottommost y to topmost y. Does it have a bottommost y? Yes, it does. Its lowest y value is right here at -1. -1 in the y direction. What is its topmost y value? It is headed up to positive infinity. So this will be from -1 to positive infinity. And we're going to make those open intervals. Let me back up a second. Okay, let me fix one thing. When you're talking about range, it's not open intervals, domain and range. That was only with increasing and decreasing. A value of the range does include -1, unless it had been an open circle there. So we will use a bracket there. All right, what are the zeros of the function? Now, we'll talk about these more later, but zeros are the same as the x-intercepts. X-intercepts. Okay, the left zero of the function is 2. Okay, x-intercept at 2. And the right one is 4. It's kind of odd the way they just had us get one of them, but that's what they said. The y-intercept is, now it will not be as difficult to read when you're doing my math lab, but the y-intercept is right here, and that is 8. Over what interval is f increasing? Okay, I'm going to erase everything on there. As I travel along, it is constant, it is decreasing, and then it turns and it is increasing. And it changes right here, and it changes right here. So in the x sense, this is negative infinity. In the x sense, as I go this way, it's positive infinity. So increasing. It is increasing from x equals 3 to positive infinity. That will be an open interval. 3 to positive infinity. Decreasing. It is decreasing from x equals 0 till x is 3. Constant. It is constant from x out at negative infinity until x hits 0. So make sure that you're thinking about what x is. So that will be from negative infinity to 0. Increasing, decreasing, and constant, we're always going to write those as open intervals. And when I say open intervals, I mean I'm using parentheses. What is the number at which f has a relative minimum? So it wants the x. Then what is the relative minimum? It wants the y. So let's go look at the minimum. All right. The minimum occurs here, and that is the point 3 comma negative 1. 3 negative 1. At 3, the minimum, the bottommost y function value is negative 1. Somebody might ask you, well, which one is the minimum? It is the y that's the minimum. It's at what x? All right? What is f of negative 4? They're saying x is negative 4. What is the y? So back up here. So when x, when x is negative 4, negative 1, negative 2, negative 3, negative 4, it hits the graph up here. So this is the point that is at negative 4. The y value is 8. So f at negative 4, so sorry, so f of negative 4 is 8. What are the x values where f of x is 3? The leftmost x value where f of x, remember f of x is another name for y. When y is 3 is when x is 1. The rightmost x value where y is 3. Okay, let's go back up here. All right. When y is 3, we have two different x's. This is the point 1, 3, and this is the point 5, 3. They mention 1, 3, and I think they're asking us about 5, 3. The rightmost value, x is 5. Is it even, odd, or neither? It did not have any symmetry, so it was neither. All right, a few more topics dealing with functions. We're going to look at something called a piecewise function. A piecewise function is a function that has been broken into different definitions for different parts of its domain. Now, if we looked at the function f of x is equal to 2x plus 1, and its domain is all real numbers, then from negative infinity to positive infinity, it behaves like this definition. If x is 1, I plug it in here and I get 3. If x is negative 2, I plug it in here and I get negative 3. So no matter what, this is the definition that relates to all the points on this graph. But when you have a piecewise function, you get different pieces. This is saying f of x is equal to, I'm going to use the y notation. Y is equal to 4x plus 3 only if x is less than 0. But y is equal to this other definition, x plus 5, when x is greater than or equal to 0. 0 is the changing place. Now, if it says what's f of negative 3, they're telling you x is negative 3. Is x equal negative 3 in this part of the domain or this part of the domain? Well, it's a negative number, so it's in this part. So I use this definition. So I will use f of negative 3 is equal to 4x plus 3. It is 4 times negative 3 plus 3, which is negative 12 plus 3, or negative 9. When they say to find f of 0, I look and say x equals 0, that's my x. Is that in this part of the domain or this part of the domain? Well, it's in this part, so I will use this definition. So f of 0, I need to use x plus 5's definition. So that's 0 plus 5, that's a 0, which is 5. So depending on the x, you pick the definition based on which part of the domain this number falls into. So when they say find f of 4, is 4 a number less than 0, or is 4 a number greater than or equal to 0? Well, it's greater than or equal to 0. So for f of 4, I pick x plus 5, plug in 4 plus 5, which is 9. You plug into either this definition or this definition depending on whether the x value makes this true or makes this true. All right, let's move on. Shrink this down a little bit. All right. It says, the full domain of the piecewise function is negative infinity to positive infinity. All right. Now, this got a little bit squished when it got typed, but here's what it's saying. F of x, which we know is y, is 4x when x is less than or equal to 0. But it changes its look, and f of x is the constant 3 when x is greater than 0. Now this is a slanted line. This is a constant. So when x, everything is going to change at x equals 0. Now this one, the behavior changes at 0. So does this one, so does this one, so does this one. So let's look at just this side. When x is less than or equal to 0, it is supposed to be the line y equals 4x. Now, y equals 4x has a positive slope, and it is, if I could graph it over the whole domain, it is an increasing line. It is increasing, increasing. But this is only the picture when it is less than 0. So only this part. And at 0, yes. This one, if I could draw it everywhere, this is a horizontal line at y equals 3. But this is only true when x is greater than 0, so it's only this side. Is it on this line when it's equal to 0? No, it's only when it's greater to 0, so that piece gets a hole. So if we look at these, I believe this is the right graph. So it has the increasing slanted one, including 0, and then it has a hole here, and all of that is at 3. All right, the range. The range, we're supposed to use interval notation. If it's just points, we use set notation. All right, so we're going to have to be careful. From negative infinity till it hits 0, well, let me rephrase. I was thinking about increasing, decreasing. The range, negative infinity goes all the way up, it hits 0 and it stops. So from negative infinity to y at 0, including 0, and it stops. Then it picks up again, so we use our union symbol. And what is the y value for every point on the whole rest of the graph? It's just 3. So we will use set notation with 3. I know that's a little complicated. It has a lot of different symbolism, but the range, the bottom to the top, it starts at negative infinity, goes up to goes up to 0 and stops. And then it picks up again at 3, but it's never anything except 3. So that's its range. Let's look at number 16. It's another piecewise function, and it says f of x is x plus 3 when x is less than 2. And f of x is x minus 3 when x is greater than or equal to 2. So I'm just going to think about this one for a minute. X plus 3, 1, 2, 3, and it's going to look like this. But it's only when x is less than 2. So there would be a hole at 2, and it would be all of this part down here, and nothing up there. If I draw this one, 1, 2, 3, it's the same kind, it's a parallel line, but it's only valid when x is greater than 2. Greater than 2 is this direction, so this won't count. So I've got this piece with a hole, and I've got this piece with a dot. And if I put those together, I believe I will have choice B. There are some ways to get the graphing calculator to do this, but it is more difficult than thinking through it on your own. Now the range. Remember, the range is all of the y values. All right, this is from negative infinity because it just keeps going down, 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 and it goes up, and there's no overlap, so it is a function, but doesn't it go up forever? The answer is yes. This has a range from negative infinity to positive infinity. All right. We're going to leave our piecewise functions and go back to something else that is review from the previous lesson. Do you remember the difference quotient? The difference quotient, it's right here. The only difference is they're not using letter A. They're sticking with f of x. So, step 1, I'm going to find, let me write down the function. F of x is equal to 3x plus 6. Do you remember that my answer ought to be 3? Well, let's see. I have f of x plus h. Okay, I'm supposed to put x plus h in the place of x. 3 parentheses x plus h plus 6. That gives me 3x plus 3h plus 6. Step 2 is to look at f of x. Well, it was given. It's 3x plus 6. Step 3 is to subtract those. It's f of x plus h minus f of x. So parentheses 3x plus 3h plus 6, got it from right here, minus parentheses f of x, which is 3x plus 6. Use my red pen. Change, change, change. So I'm going to have 3x plus 3h plus 6 minus 3x minus 6. The 3x's cancel, the 6's cancel. You're left with 3h. Step 4 is to take f of x plus h minus f of x, that's what we just got, divide it by h. So that's 3h over h, which is 3. Is that what we predicted? The difference quotient, which has a difference and it is a quotient, gives us the slope when the function is linear. Now our last problem, the function is not linear. The answer we get is not going to be 2. You cannot find a number that represents the slope of a quadratic function. So there's the study of this moves us into calculus. We're not going to go that far, but that's what happens. So first I want to find f of x plus h. That is, here's my function. X plus h in parentheses squared minus 2 times x plus h plus 3. Squared binomial, x squared plus 2xh plus h squared. Distribute the negative 2, minus 2x minus 2h plus a 3. And there's nothing I can do to simplify that. F of x, which is given, is x squared minus 2x plus 3. If I'm going to now find the difference, I'm finding f of x plus h minus f of x. So it is x squared plus 2xh plus h squared minus 2x minus 2h plus 3, and that's all just f of x plus h minus parentheses x squared minus 2x plus 3, and that's f of x. Well, all right, so I'm going to change it to plus, minus, plus, minus. So I have x squared plus 2xh plus h squared minus 2x minus 2h plus 3 minus x squared plus 2x minus 3. The x squareds go. The 2x's go. The 3's go. And I am left with 2xh plus h squared minus 2h. I'm left with this term, and this term. The last part of my problem is to take f of x plus h minus f of x and divide it by h. So I'm going to take what I got for an answer, 2xh plus h squared minus 2h, and divide it by h. Well, is this the answer, or can I do something? Hopefully you see that h is a common factor in the numerator, and if I factor it out, that leaves me with 2x plus an h minus a 2 all over h. Those divide out, and you get 2x plus h minus 2. That is the answer to the difference quotient. It does not have much meaning to you right now, but if you go on into higher math, you will do more with this, and it will have something to do with the slope. All right, that's a lot of different topics. Keep your notes handy. Use your formula packet for even and odd, difference quotient, and so on.